Hello, pre-calc students. This is Mr. Lal here, going over the solutions to Common Assessment 3. Hopefully with these video solutions, you should feel like you are in a position where you can correct your solutions with pen. All right, let's get started with question 1. The value of the car depreciates at a rate of 7% each year. The car was bought for $13,412 in 2017. What year will the value of the car hit $5,000? So starting off with this problem, we need to recognize this as an exponential decay problem. So depreciates at 7% each year. That's the same as each year it's being multiplied by 0.93. So if you multiply by 0.93, that's going to be the same as depreciating at a rate of 7% each year. That being said, we need to figure out when the car will hit 5,000. So we can set up the exponential decay problem. $5,000 is going to be equal to, our starting value is 13,412 times each year it's being multiplied by 0.93. 0.93 to the t power. So what we can do to solve this is we need to isolate t to figure out how long it takes to depreciate from $13,412 to $5,000. So we need to isolate t. So first step is to divide each side by 13,412. And this will cancel out. Take my calculator here, if this works. We can do the problem 5,000 divided by 13,412. That's going to be about 0.3728. So let's actually store that value as a. So this value right here, we'll have this stored as a. So I'll say STO as a. So a is equal to 0.93 to the t power. Then to find t, I can say that the log, so we need to swoosh the logarithm, the log of 0.93 of our a value, so of a, remember that in this case a equals 0.3728 continuing on, is equal to t. So in order to, I can't do it on my calculator, I can do the log of a divided by the log of 0.93 to evaluate the logarithm. Use the change of base formula. So that will be 13.59. All right. So t is equal to 13.59. And so to find out in what year will the value of the car hit 5,000, if it takes 13.59 years for the car to hit 5,000, we start in 2017, then we add 13.59 years. and you're going to end up in the year 2030.59, which will simplify to 2030. So that is our answer, and our answer is C, 2030. So that was the first problem. Let's keep on going. What is the domain of the function f of x is equal to x plus 2 over x squared minus 6x plus 8. So to find the domain, we will need to factor the denominator. So I can rewrite this equation as f of x is equal to x plus 2 over 92 terms that are going to multiply to 8 and add to negative 6. And those values, and if it multiplies with 8, we could do, how about 4 and 2? Negative 4 times negative 2, multiply to 8 and add to negative 6. That will be negative 4 and negative 2. That being said, that will be x minus 4, x minus 2. So that's the domain of function x plus 2 over x minus 4, x minus 2. And now we can see that for the domain of the function, we need to make sure that we are not divided by 0. So remember, for the domain, you cannot divide by 0. So because you cannot divide by 0, you make sure that none of these denominator terms would be equal to 0. So if x minus 4 cannot equal 0, and x minus 2 cannot equal 0, that means x cannot equal 4, and x cannot equal 2. Setting up the domain and interval notation, if x cannot equal 4 or x cannot equal 2, then x in interval notation, that's just going to be from negative infinity to 2 union 2 to 4 union 4 to infinity. So that is answer choice D. Moving on, what is the range of the function f of x is equal to negative 12 times x minus 2 squared plus 4? So the range of the function is going to be, well, first of all, hopefully you can see this is downward facing parabola. So this is, because this is a y equals parabola, this has a vertical orientation. So this is, and because that's negative and this is y equals, we know this has a vertical orientation. Downward facing. And we have a vertex. Remember our standard form for our parabola, or at least for vertical parabola, is going to be y is equal to 1 over 4p times x minus h squared plus k. So hk in this case would be, when we switch the sign for h, not k, positive 2, positive 4. So we have a vertex at 2, 4, and then we're down facing, so the parabola is going to be down facing as such. So looking at this type of parabola, it's going to go down towards negative infinity, but the highest point will be at 4. So our range is from negative infinity to 4. All right, let's move on to problem 4. What value of k would make the function continuous? Making the function continuous, you have f of x is equal to negative 2x plus 6 times, when x is less than negative 2, 4kx minus 6 when you are from negative 2, when x is greater than or equal to negative 2 but less than or equal to negative 3, and then 12 when x is greater than 3. So first we need to try to make the first function and the second function in this piecewise function continuous. And remember, the first function and the second function are going to meet when x is equal to negative 2. So we have to set up the equation negative 2 times negative 2 plus 6 is going to equal 4k times negative 2 minus 6. So let's solve for k. Negative 2 times negative 2 is positive 4 plus 6 is 10. 4k times negative 2 will be negative 8k minus 6. Add 6 to each side. 16 is equal to negative 8k. Divide each side by negative 8. And k is going to be equal to negative 2. So you have to have k equals, you must have k equals negative 2 in order to make functions 1 and 2 continuous, to make 1 and 2 continuous. So let's see if having k at negative 2 will okay. So that being said, now we need to see the third function is going to meet when x equals 3. So if this function equals this function when x equals 3 and k equals negative 2, then we will be able to make this function continuous. So can we have 4 times k has to be negative 2 times negative 2 times, now x is going to be equal to 3 minus 6 is equal to, the third function is equal to 12. And hopefully we can see here, 4 times negative 2 is negative 8 times 3 is negative 24. Minus 6 is equal to 12. Is negative 30 equal to 12? Nope. So therefore, the function cannot be made continuous because there's just no number that could work out to make all those functions continuous. All right, moving on. Problem 5. What transformations occurred to create the function f of x equals 4x, the absolute value of 4x minus 8, from the parent function, the absolute value of x? So let's analyze our function transformations rules for absolute value function. F of x is going to be equal to the absolute value of a well, I'm sorry. Pardon me. It should be the absolute value of plus or minus a times the absolute value of b times x minus c plus d. All right, and I should say that's a plus or minus. To be more accurate, there's a plus and minus b here. All right, so this is going to be a horizontal reflection right here. The plus and minus stands for horizontal reflection. A stands for a vertical stretch. All right, and then it's going to be a vertical stretch if A is bigger than 1, a vertical compression if A is less than 1. B will be a horizontal stretch if B is greater than 1. Or sorry, will be horizontal compression if B is greater than 1, and horizontal stretch if B is less than 1. If B is positive, you don't have a flip, but if B is negative, you have a y-axis reflection. You shift C units, and then that's your horizontal shift, and your vertical shift is D units. That being said, let's analyze this function in function transformation form. We can take this function and do 4 times x minus 8. We can factor out the 4 and have x. When you factor out the 4, we will have x minus 2. So this will give us a horizontal compression by a factor of 4. So we have a horizontal compression by a factor of 4. And we're going to shift right to all right, so that gives us choice A. All right, so that's number 5. Let's keep on going. If f of x is equal to the ln of x plus 4, what is the approximate value of the inverse of 2? So first we need to find the inverse of f of x. So that's going to be equal to, how we're going to find out? We're going to switch x and y. So x is equal to the ln of y plus 4. All right, and remember ln is log base e. So we can say x is equal to the log base e of y plus 4 if that helps us out. And we can swoosh our logarithm and rewrite it so that e to the x equals y plus 4. Isolate y so that we have y is equal to e to the x minus 4. And now we need to get the y by itself. So the inverse of the function is going to be equal to e to the x minus 4, right, an inverse notation. So we need to have the inverse of 2. So in this case, the inverse of 2 would be equal to e to the 2 minus 4. So let's find, with our calculator, e to the 2 second power minus 4. That will give us 3.389, which is approximately 3.39, which gives us the answer 3.39. Great, moving on. Three friends, Anna, Barry, and Clyde, are camping in the woods. They set their tents up in a triangle. Anna and Barry are 10 feet apart. The angle formed at Barry's tent is 30 degrees, and the angle formed at Clyde's tent is 105 degrees. Approximately, how far apart are Anna and Clyde? Well, we need to create a triangle here with sides A, B, and C. Anna and Barry are 10 feet apart. This is not going to be to scale, by the way. The angle formed at Barry's tent is 30 degrees. And the angle formed at Clyde's tent is 105 degrees. Approximately how far apart are Anna and Clyde? So we need to find this length right here. And because we have an included angle, an included side, and then we have a side that we need to find. So let's solve for x here. So we need to have a side we need to find, and the angle opposite of it, we can use the law of sines. So the law of sines will say that, in the law of sines, to find a side, we can say that we're looking for side length AC. So line segment, or triangle segment AC, which is opposite of side B, over the sine of B is going to be equal to 10 AB over the sine of C. 10 over the sine of 105. So this length, we can call this X or side B. And 10 could be called side C. That could also be called side C, whatever you put it. But we need to solve for X or side B. So, and the sine of B here, that's 30 degrees. So X is going to be equal to 10 times the sine of 30 degrees. So I multiply each side by the sine of 30 degrees. And these sines of 30s cancel out. So 10 times the sine of 30 degrees over the sine of 105 degrees is going to be equal to the length of x. So let's make sure we're in degree mode. We are in degree mode, and then we can do the equation. 10 times the sine of 30 degrees divided by the sine of 105 degrees. That's going to be 5.176, which is approximately 5.18 feet. So that's problem 7. So we remember you have to know the law of sines here. So the abstract form of the law of sines for this problem would be b over the sine of b is equal to c over the sine of c. Remember, you can flip if you're solving for an angle, it's a bit easier to flip the ratios. Two friends of equal height are standing on the same linear street and both are looking up at the Statue of Liberty. Richard looks up at an angle of 34 degrees, while Demea is looking at a height of 61 degrees. If the Statue of Liberty is 305 feet tall, approximately how far apart are the two friends? So how much space do I have here? Okay. I have a little bit, so let's draw this out here. You have this one guy who, for the Statue of Liberty, all right, two friends, Anna, Barry, and Clyde, are standing on a linear street at the Statue of Liberty. Sorry about that. All right. So, Richard looks up at an angle of 34, while Demaya looks up at an angle of 61. The Statue of Liberty is 305 feet tall. Approximately how far apart are the two friends? So this will be the Statue of Liberty. All right. The Statue of Liberty is going to have a height of 305. So that has a height of 305. And Demaya is going to look up an angle of 61. So Demaya is going to look up at an angle of, let me draw that a little bit better, 61 degrees, while Richard is going to look up at an angle of 34 degrees. And we need to find the distance between these two people. So let's find the distance of these right triangles. Well, for this distance, I can use right triangle trigonometry, knowing that 305 is the, it's going to be the opposite side. And this is the adjacent side for both of these triangles. For this height too, you're looking at the adjacent side. So we know that from SOHCAHTOA, we know that cosine opposite over adjacent, or tangent. So with the tangent function, value, the tangent of 61 degrees is equal over adjacent 305 over d. So the tangent of 61, which means that we do some multiplication here. D times the tangent of 61 is equal to 305, which means D is equal to 305 over the tangent of 61. Let me 305 over the tangent of 61 degrees. And by the same logic, R would be equal to 305 over the tangent of 34. So with our calculator, we can do the problem. If this calculator will work. (305) divided by the tangent of 34 degrees. So that's going to be 452. So this value is 452. feet, and then 305 over the tangent. Sorry. This is 452, and then 335 over the tangent of 61. That's going to be 169. This value will be equal to 169. So therefore we can do 452 minus 169. And that answer will be 283, which is our answer right here. So that is that problem. That's problem 8. Problem 9, I think problem 9 can best be done by first just visualizing the problem, and then after that, after you visualize the problem, plugging into your calculator or solving it step by step. So I'm going to do both examples. So the function right here is going to be negative 25 times the sine of pi over 12 t. In this case, t is our variable, so that can be x, plus 6. All right, and then we need to choose an appropriate window. So it looks like we need to make sure our height fluctuates between 31 and negative 31. So let's change our window so that our y max is at least 42. Do the same thing on the negative side. The y min will be negative 42. And because we're at least starting, remember we're starting at 12 p.m. and it takes a full 12 hours to go to 12 a.m. and then 18 hours to go to 6 a.m. We need to at least have an x window our x window can start at 0, but we need to go at least 18 hours out. So let's do a full 24 hours out into the day. All right. Graphing the function. And this is what the function is going to look like. And this makes sense because this is a sine function. It's a negative sine function. And a negative sine function, first you start at your midpoint. Normally you go to a maximum because it's a negative sine function. You're going to go to a minimum, and you go back to the midpoint, then you go to your maximum, and you go to your midpoint. And so we need to find the maximum. And so note that the maximum is going to be the absolute value of the amplitude plus your vertical shift. So that maximum would be the absolute value of -25 plus your vertical shift 6. So the absolute value of -25 is 25. 25 plus 6 is 31. All right, 25 plus 6 is 31. Okay? 25 plus 6 is 31. So, by the way, that's going to be a maximum right here, so we can narrow it down to these two. Now let's find the maximum here. Because when we read the problem, we need to know how high and what time does the tide reach the highest point above the seashell. And note that we're going to start out at 12 p.m. when t equals 0. And we need to figure out how long it takes before we get to our maximum, all right? And the how long it takes, that's going to be this length right here. We'll call this t. We'll have the coordinate here, t, s of t. Remember, s of t is 31. So we need to find the, for lack of a better word, x coordinate to find out how much time has passed. So let's find the x coordinate. We go to second, calc, find our maximum value. And also, just a heads up, make sure you are in radian mode. But we find a left-bound point. You find a right-bound point. And you take your best guess. And here we'll have a maximum of 17.99999631, which is pretty much, we can pretty much say that that's going to be 1831. And so what happens when you go 18 hours past 12 p.m.? When you go start at 12 p.m., you go 12 hours, that gets you to 12 a.m. So we need to have another 6 hours to go. You go your last 6 hours, 12 a.m. plus 6 hours, that's going to give us at 6 a.m. So our time is going to be 6 a.m. We're going to have answer choice D. All right. So you just got to be able to set your window in your calculator. That's very important. But moving on, let's go to problem 10. If a parabola with a focus has a focus with the coordinates of 2, 2 and a directrix at y equals 4, what is the equation of a parabola? So let's draw things out here. we have a directrix at y equals 4. So draw a little xy axis here. We have a directrix at y equals 4. And we have a focus at 2, 2. So our focus is at 2, 2. We need to know that the vertex is the midpoint between the focus and the directrix. So the midpoint between 2, 2 and y equals 4 is going to be this point right here. And that point is going to be our vertex. Will be at, the x value stays the same, would be at 2, 3. And just note that the vertex is the midpoint between the focus and the directrix. So the vertex is the midpoint between the focus and the directrix. Let's get it done. So in that saying, now we take the standard form of a horizontal hyperbola, or of a vertical hyperbola, because this hyperbola is going to go as such. Also, because we go from our vertex down to our focus, our focal length well, it's equal to 1. Because we're going downward, P, or some people call it C, is equal to -1. And that's because we are facing downwards, downward facing parabola, so P or C is negative. So we take the standard form of a vertical ellipse. Y is equal to 1 over 4c times x minus h squared plus k. And make sure that we plug in our values here. So remember, hk is 3, 2. So sorry, hk, that's going to be 2, 3. And c is equal to -1. So y is equal to 1 over 4 times -1 times x minus, the x value is 2, squared plus 3. So that becomes y is equal to -1/4 times x minus 2 squared plus 3. And that's going to be answer choice D. So you got to make sure that you got to know that find the midpoint between the focus and the directrix. Know your equations for parabolas, and then be able to plug in your focal length and your vertex into your equation. So that's problem 10. What are the locations of the foci of the hyperbola below? Oh, geez. Guess I messed up formatting this document. Oh, that's okay. So the foci of a hyperbola, when this is a horizontal hyperbola, and so a horizontal hyperbola because the x term is positive, so anyways, the foci of a horizontal hyperbola are going to be h plus or minus c k. All right. And to find the Pythagorean relation of hyperbola, the Pythagorean relation is c squared is equal to a squared plus b squared. And c squared, remember 4 in this case would be equal to a squared. 9 would be equal to b squared. This is from the standard form of hyperbola. So also know the standard form of hyperbola for at least a horizontal hyperbola, x minus h squared over a squared minus y minus k squared over b squared is equal to 1. All right. So c squared is equal to a squared plus b squared. So c squared is equal to 4 plus 9. So c squared is equal to 13. C is equal to the square root of 13. So if c is equal to the square root of 13, and the foci hyperbola is h plus or minus c comma k, then that would be 3, because the center of x minus 3, x minus h, so you change the sign, 3 plus or minus c, square root of 13, comma, y plus 4, change the sign, negative 4. So that's going to be answer choice C. Problem 12. The eccentricity of a comet's orbit around planet X is 0.549. So the big thing I have to remember here is eccentricity for an ellipse and hyperbola. Eccentricity is equal to c over a. All right. The comet's orbit has a major axis length of around about 610,000 kilometers. What is the approximate length of the orbit's minor axis? So what is the approximate length of the orbit's minor axis? All right. You have a major axis length of 610,000, okay? So let's just draw an ellipse here. You have a major axis length of so this length is 610,000, okay? We need to find the length of the minor axis, so we need to find this length right here. So we need to find this is x, and our eccentricity is c over a. So we got to know that 610,000 is equal to the major axis length. So 2a is the major axis length. So the major axis is 2a, so therefore divide each side by 2. And 305,000 is the length of a. And the f for eccentricity is c over a, which means 0.549 is equal to c, which is c, which we don't know, over a, which is 305,000. So using some algebra, multiply each side by 305,000, and 0.549 times 305,000 thousand is equal to c. So $305,000 times 0.549 equals 167,445. So C is equal to 167,445. So now we need to use the Pythagorean relation of the ellipse. So our Pythagorean relation for an ellipse is that a squared is equal to b squared plus c squared. But here we need to solve for b. So we can say b squared is equal to a squared minus c squared. Or b squared is equal to a squared 305,000 squared minus c squared, which is going to be 167,445 squared. So that's going to be, oh, let me, I need to use parentheses there. So, oh, and then, well, actually, no, that's just going to be b, right? So, and then I should be able to store this value as a, and then I can, so that's a now is signified as this value. Take the square root of a, which is this value right here, 6.498 times 10 to the 10th power. And that should give us b right there. Multiply that by 2, and we get about 510,000. So here's what we did here. B squared is equal to a squared minus c squared. So we plugged in b squared is equal to 305,000 squared minus 167.445 thousand squared, right? And so that this was 6.4 times, this was approximately equal to 6.498 or 6.499 times 10 to the 10th. Then I took the square root of each side, meaning that b is approximately equal to b is equal to about 254,925, but the semi-minor axis, so the minor axis, so this is the semi-minor axis, the minor axis, that's equal to 2b. So that's going to be equal to, multiply each side by 2, that will give you 509,851, which is approximately equal to 510,000. That is problem 12. Two ships are sailing directly out of the Boston Harbor. The SS Minnow sails directly east, while the SS Shark sails 30 degrees north of east. If after 3 hours the SS Minnow has traveled 200 kilometers, as the shark has traveled 150 kilometers, approximately how far apart are these two ships? So let's start at the center, okay? SS Minnow sails directly east, so we have the Minnow sailing directly east, and how far does Minnow go? 200 kilometers. The shark travels 30 degrees north of east, so we go 30 degrees north of east. And travels 150,000. All right. So how far apart are these two ships after this time? And find this length. All right. And we can what we can do is we don't have the opposite side length. So because we have side angle side, right? So we have a side angle, side triangle. We can use the law of cosines. All right, so let's solve for x. Right? Using the law of cosines, remember x is the side opposite of 30. 200 and 150k. Sorry, and there's no. Oh, these are kilometers. Sorry, 50 kilometers. These are the sides not opposite of 30. So we can say x squared is equal to 150 squared plus 200 squared minus 2 times 150 times 200 times the cosine of 30 degrees. 1 second. So this is the law of cosines right here. So to find x will be equal to the square root of 150 squared plus 200 squared minus 2 times 150 times 200 times the cosine of 30. Okay? So we can take our calculator and solve it. Make sure we are in degree mode. And have x is going to be equal to the square root of 150 squared plus 200 squared minus 2 times 150 times 200 times the cosine of 30 degrees. So I have 1, 2, boom, 1, 2, 3, 1, 2, 3. And that's going to give us a value. Plug that into the calculator. So evaluate this value in the calculator. And x is going to be equal to 102.65, which is approximately equal to 103. All right. So Rodney attempts to swim across a point on the Mississippi River that flows directly south at the speed of 4 kilometers an hour. If Rodney swims directly east across the river, his speed is still at his speed is, in still water is 8 kilometers per hour. What is Rodney's resultant speed? So let's look at Rodney right now. All right, so Rodney's resultant speed, if you think about it, the river is going to have a vector going directly south at a speed of 4 kilometers an hour. So that's going to be one component. All right. Then Rodney's going to try to swim directly east, and his magnitude when he's Rodney's magnitude alone is 8 kilometers an hour. Okay. All right, so we need to find Rodney's resultant speed, which is the hypotenuse of this right triangle, because that's his resultant vector. So we can use the Pythagorean theorem here. We can do 4 squared plus 8 squared. Take the square root of 80 using the Pythagorean theorem here. And the answer is going to be 8.94, and that's answer choice C. So we need to find, this is the resultant vector right here. Resultant vector, and we can find the resultant vector through the Pythagorean theorem. So that's going to be equal to the square root of 8 squared plus 4 squared, which is equal to 8.94. Problem 15. Which equations represent the rectangular equation for the graph formed by the parametric equations x is equal to 3 times the square root of t and y equals 12t squared? Well, first we need to eliminate the parameter. Eliminate the parameter. So if x is equal to 3 times the square root of t, then x over 3 is equal to the square root of t, and x over 3 squared is equal to t. Now we can plug t into the y equation. So y is equal to 12 times x over 3 squared squared. So that's going to become y is equal to 12 times x over 3 to the 4th power. All right, so y is equal to 12 times x over 3 to the 4th power. So let's try to simplify things now. We have x to 3 over 4th power is going to become y is equal to 12 times x to the 4th over, and then 3 times 3 is 9, times 3 is 27, times 3 is 81, over 81. So you're going to get y is equal to 12x to the 4th over 881. I'm sorry. Let's see, this x over 3 squared is equal to t. And so then one last step is that I can divide each side by 3. So if I divide this side by 3 and divide this side by 3, 12x to the fourth divided by 3 is 4x to the fourth, and 81 divided by 3 is going to be 27. So that just simplifies the fraction, because 12 over 81 is going to simplify to 4 over 27. So that's why you get, instead of 12x to the fourth over 81, it's more simplified to say 4x to the fourth over 27. So that's problem 15. Problem 16. What is the approximate eccentricity of the ellipse graphed by the set of parametric equations below? So first, when you have parametric trig functions, all right, we need to isolate our trig values. So x, so the cosine of t is going to be x minus 3 divided by 2 is equal to the cosine of t. For y over negative 4 is going to equal the sine of t. Now, the Pythagorean relation that we need to know, Pythagorean identity, and this is for trig, is that the sine of t squared plus the cosine of t squared is equal to 1. So if y over negative 4 is the sine of t, then y over negative 4 squared is the sine squared of t. And if x minus 3 over 2 is the cosine of t, then x minus 3 over 2 squared is the cosine of t. And that's all equal to 1. So let's simplify this. Let's expand this out. Y squared is y squared, and negative 4 squared is 16. Plus x minus 3 squared, we can write as x minus 3 squared. And this will be 4. And so we need to recognize that this is a vertical ellipse. Well, we don't actually have to recognize that, but it's extra bonus points. Hypothetical bonus points, not actual bonus points. And that eccentricity is equal to c over a. 16 is the larger denominator, so that's equal to a squared. 4 is the smaller denominator, that's equal to b squared. Your Pythagorean relation for an ellipse is that a squared is equal to b squared plus c squared. So that means 16 is equal to 4 plus c squared, which means c squared is equal to 12, and c is equal to the square root of 12. And if 16 is equal to a squared, then 4 is equal to a, and eccentricity is c over a. So c over a is equal to the square root of 12 over 4. Get our calculator out. Find the square root of 12 divided by 4. And that's equal to 0.866, which is approximately equal to 0.87. So that's, with our calculator, this is equal to, it's approximately equal to 0.866. We used our calculator, let's note that, which is going to be equal to 0.87. Number 17. The polar coordinates of a point are 8, 210. What are the rectangular coordinates? So we need to know our polar to rectangular conversion formulas. X is equal to r cosine of theta. Y is equal to r sine of theta. Remember, these are in degrees. And 8 is r, and 210 degrees is theta. So x is equal to 8 times the cosine of 210 degrees, and y is equal to r times the sine, 8 times the sine of 210 degrees. So let's make sure we are in degree mode. We are. 8 times the cosine of 210 degrees. That's negative 6.928. And let's see if that's negative 4 root 3. Negative 4 times the square root of 3 is the same value, so we know that's right. So this is x is equal to negative 6.928, or negative 4 times the square root of 3, and y is equal to 8 times the sine of 210. So that's going to be equal to negative 4. So y is equal to negative 4. So our polar coordinates are negative 4 times the square root of 3, comma, and negative 4. And that's going to be answer choice B. Moving on to problem 18. Which polar coordinates are equivalent to negative 3, the point negative the square root of 3, comma 1, if our angle is in between 0 and 2 pi radians. So let's use our other polar coordinate formulas, okay? So we need to convert from a polar coordinate into a rectangular coordinate. So actually 5 pi over 6, that'd be sorry about that. My pen glitched a little bit. That would be look like 5 pi over 6. This would have a length of 2. Find the coordinates of this point. And so we need to know that for our polar coordinates, theta is equal to the inverse tangent of y over x, and r is equal to the square root of x squared plus y squared. So let's find theta. Theta is equal to the, and I'm sorry, we don't know the right answer to begin with. So let's pretend we didn't look at this, and we're just looking at these rectangular coordinates, okay? So theta is equal to the inverse tangent of y over x. So let's find the inverse tangent. Make sure we're in radian mode this time. I'm going to find the inverse tangent of 1 over the negative square root of 3. So that's going to be up mode. Go back to radian mode. And once again, find the inverse tangent of 1 over the negative square root of 3. The negative square root of 3. So, and by the way, let's make sure that this value is equivalent to 5 pi over 6. 5 pi over 6 is equal to, okay, here's what we'll do. We have our theta value is equal to negative 0.651. All right, but our theta value needs to be in between 0 and 2 pi, so we need to make this value positive. So in order to make this value positive, what we can do is we could actually add pi to end up in the same spot. So in this case, when we have an x value that is negative square root of 3, because our x value is negative, and our y value is positive, that's going to put us in quadrant 2. And because we are put in quadrant 2, when we have negative 0.651387887, we can add pi to get our value. One, 3, 8, 7, 8, 8, 6, 7. Okay, good. And then for our 2 value, we can just find the square root of square root of 3 squared plus 1. So that's r is going to be equal to the square root of x squared. That's going to be 3 plus 1. So that's r is equal to the square root of 4. R is equal to 2. So we know r is equal to 2. So either C or A. But then we need to find out 5 pi over 6. We also know 5 pi over 6, that's a quadrant 2 angle. And so, because it's a quadrant 2 angle, we can do C. You can also convert your radians into degrees if that makes it easier for you. Because if you converted radians to degrees, you could do 5 pi over 6. To convert from radians to degrees, you multiply by 180 over pi. That's 150 degrees. And because this is 150 degrees, this is clearly there's no other way to put it. That's the quadrant 2 angle. So this is the only one where r is 2 and you have your quadrant 2 angle. All right. Moving along. Which equation is the polar form of the rectangular equation below? Let's solve this step by step. R is equal to 8 times the cosine of theta. So our goal here is to use our polar conversion formulas to isolate R and get things on the right hand side. So what can we do? We can have x minus 4 squared plus y squared is equal to 16. Our polar equations are going to be r squared is equal to x squared plus y squared. We also know that the x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So if we expand this out, this will be x squared minus 8x plus 16 plus y squared is equal to 16. I can subtract 16 from each side. So I get x squared minus 8x plus y squared is equal to 0. Now my next step is to add 8x to each side. So I have x squared plus y squared is equal to negative 8x. I have an x squared plus y squared here. This is part of my conversion formula. I have a negative 8x. I have an x here, which is another part of my conversion formula. So x squared plus y squared, that will convert into r squared. And negative 8x has become negative 8x is equal to r cosine of theta. Divide each side by r. And r is equal to negative 8 times the cosine. When I add 8x to each side, that's going to be positive 8x. So that's going to be positive 8 times the cosine of theta, making my answer choice D. I can also see this is a circle. Radius 4. Center at 4, 0. And if I recognize 8 cosine of theta as the only polar circle, if you end up graphing all the answer choices in polar mode, so I can go to polar mode and know that r is equal to 8 times the cosine of theta. Graph that jaunt. Let's do zoom. Standard. All right, this is the really only option for r is equal to 8 times the cosine of theta. This is a circle with the center at 4, 0. So if you can do the algebra, or you can just know how to interpret this, this will both give you the correct answer. All right, moving on to 20. What are the Cartesian coordinates of the center of the circle graphed by the polar equation? R is equal to the cosine of theta minus 4 times the cosine of theta minus 4 times the sine of theta. So we need to use our polar conversion formulas again to convert to Cartesian. So our first step is let's multiply each side by r, because this gives us, if you can see, this gives you an r squared on the left side and a 4r cosine and r sine of theta on the right side. So you can get r squared is equal to 4r cosine of theta minus 4r sine of theta. All right, you have an r cosine of theta, an r sine of theta, and an r squared. These are your conversion formulas. R squared is equal to x squared plus y squared. So you got to know that r squared equals x squared plus y squared. This is in the memorized bank. You also know x is equal to r cosine of theta y is equal to r sine of theta, which is equal to 4x minus 4y. And let's simplify this out here. Get everything on one side. X squared minus 4x plus my complete the square term plus y squared plus 4y plus my complete the square term is equal to my 2 complete the square terms. To find my complete the square terms, that's going to take negative 4 divided by 2. That's negative 2. Square it. That's 4. And for the same thing, 4 divided by 2 is 2. Square it. That's 4. So I will get the equation x squared minus 4x plus 4, which will factor into x minus 2 squared, negative 2 here, plus y, the y terms, plus 2, positive 2, squared is equal to 4 plus 4 is 8. So our radius is the square root of 8, and our center is equal to 2, negative 2. So if we know to interpret the circle from the equation, the center becomes 2, negative 2. And in that case, that's answer choice C. All right, that's the entire video for the quiz. Have a great time.